Hello, everybody. Mic check. Okay. Did Django? So I'll be talking about implementing domain-driven design in Django. My name is SebCorbin, Sébastien Corbin en français. I've been doing Python and Django since 2016. Before that, I was doing PHP and Drupal, but I came to the bright side. It's been 10 years that I've been doing web development, and I'm a local meetup co-organizer and a tutor. I work for Machina Corpus, which is a small-size agency in France. We do Python and PHP. We also do front-end, and here are some packages that you may know from us. We also have products. Here are two products. GeoTrack is a trail and natural park managing tool. And LocoKit is a low-code kit written in Node.js that you may have a look at. It's a bit like Airtable. Okay, so I'll be talking about the OSIS project. The OSIS project is a project from UCLouvain, so Université Catholique de Louvain-la-Neuve, alias UCL. It means OSIS means Open Student Information System. They have been working on it since 2016. And I think the dev team is over there. I don't know. But, oh yeah. So if I say bad things, they will fire me. So you can find the code on GitHub. And it's almost open source. They have, unfortunately, they've been closing the core recently for security reasons. But I'll be showing OSIS admission sub-project, so the code will be from that. Okay. About OSIS, the business is quite large. They have a student admission system, which treats lots of levels, student level. They also manage the student once it has been admitted, the courses, the catalog of examinations, tutor applications, assessments, and so on and so on. So as of our part, Machina Corpus has worked on partnerships 3 years ago, and now we are working on admission. So as you can see, there is a lot of stuff to implement and maintain. It's a large project, and the architecture handles 35K students and 6K of staff members, and it has to be security-oriented because of the data it handles. So for that, there is 2 servers and 2 Djangos that communicate together through an API. The back office is only accessible through a VPN, and it's an internal portal that the staff members connect on, and manager administrators. And for the front office side, well, it's accessible for students and tutors, and it communicates through the API. So it's a large project. There are about 250 models. And yeah, that's it. So it's a big monolithic app, but they are continuously trying to make it better. About this architecture, it's an historic decision. So we try to say that it could be replaced with a framework-based front-end, but still no luck. Okay, so that is the beast that we are fighting against. Now, what about DDD? Who here knows, have been hearing about DDD? Who uses it every day? Oh, some people, okay. So, DDD, also known as domain-driven design and not development, is an approach to a project. So it's a design approach, focusing on modeling the software to match domain, so to match business needs. And as a developer, you will find you're not the experts. The business people are the experts in the domain. So it has been theorized by Eric Evans, early 2000. And you can find these books, like the Blue Book, if you want to know more about it. So, business domain at the center. as I said, you're not the experts, so you must speak the same language as the business experts and have the same terms. For that, you can create a glossary, and it will be easier to speak throughout teams and people. Your code must reflect these terms, and these terms, they may be in French. So if your domain is expressed in French, you have to code in French. Well, it's a decision you can make, but as for us, we decided to code in French. So I will be showing code that is in French, and I will translate as much as I can, but you know, the important thing is the approach. The domain may be different for you. You may be seeing both French and English, and we like that. We like to call it Franglish as a French. Who here speaks French? Oh, nice. Lots of French people. Okay. So domain, wait. What about data? We are handling data. Django is a model-driven or data-driven framework. What would you shift to a domain? So data works, but for complex processes, the code can look like spaghetti. And once you build up on data, it becomes a lot more complex. Sorry. And when your model changes, the structure of your data changes, you risk an alteration of the process of the business you are doing. So maybe we can find a more better thing. So also, again, DDD is a lot about humans who work together. So humans change and teams change. And when you code in Django, you have a way of thinking. So the business might change, and the teams might change, and other people can come to the teams and don't understand how you did what you did. So it's more about people than programming. And I hope most of you know this kind of image. It's traditional. It means like communication between teams, between the project's members, between the customer, the clients, the business people. Sometimes it's a mess. So from time to time, you will find that the life cycle of a project is really messy. And to avoid that, we have to, we could use DDD. Well, DDD is a thing that won't work in most projects, but for long-term projects, like 5 years and more, which have lots of business domain, it really fits your needs. And you need a lot of money. So when not to use DDD? Django is a rapid application development framework. So if you have a simple CRUD, there's no need to use DDD. And if your business is already answered by one of the package that Django provides on third party, like CMSs and e-commerce, don't use DDD. If the maintenance is not needed over time, like a proof of concept, or the app is simple, don't use DDD, no. If it's a short project, like a few weeks, don't bother. And the last criteria is your dev team. If your dev team is too junior, it may be a bad choice too. Because it's another approach that people don't learn in schools or in other projects, it may be hard to grasp. And can I use DDD in my existing project? Well, yes. DDD is made like it is made to refactor some parts of your domains. So, for example, the DDD has been introduced in OSIS 5 years after the first release. So, it's a good example. Now, some common patterns that you will find in a DDD approach. We are often talking about ubiquitous language. Ubiquitous means everywhere, omnipresent. And that means like it's the most important thing about DDD. You need to take care of that, because if people don't understand each other, it will be failing fast. So you have to use the right terms across the domain and define them at the beginning before even coding. They must come from the business people, from the business side, but they can be discussed, because if there is a misunderstanding at first, the developers will refrain from coding. So another thing to note is that a term can have another meaning in another context. And once stated, these terms must be written somewhere. So as for the code, a glossary could live in a docstring in a dunder init package. So yeah, just write it somewhere. Okay, now another pattern is bounded contexts. Bounded context means separate your concerns into small parts, each one solving a problem. So for example, an object can have different name in different contexts. A user can be a customer in the commerce domain, an account in an invoicing domain, and a recipient in the shipping domain. So multiple contexts, multiple terms, multiple domains. In the code, a domain usually means a namespace. So new directory, new package, and so on. It does not mean that context cannot communicate together, but data may have to be translated between them. And from the data approach, you may store everything in a table and use it as you like. But in a bounded context, you may not need all data at all time. So even if it's closed in the storage, you might not need the payment mode when you are talking about commerce. It's just used during the invoicing, during the payment. And yeah. Another pattern is a shared kernel. Shared kernel is created when you have data that is frequently used and everywhere. It can be present at multiple levels of the project, so a shared kernel can be at the top level or in a bounded context. Well, it's to prevent duplication, but don't put everything in it, because it can have a lot of business, and that's not the goal. Now, the architecture of the code. This is OSIS architecture, sorry. But some use different approach when structuring their code. So first, you have the domain layer, which is your core business, the business domain. And then you have the repository layer that knows about the domain and manipulates data with it. And then you have the service layer that is aware of the repositories and the domain, but it doesn't know about Django, for example. And then you have the UI, the graphical UI, the presentation layer, which is basically Django, your APIs, your views, anything. So now, once we have these common patterns, we can think about directory structure. So let's say this is my project, or an app in my project. I will have a DDD repository, and this will be basic Python. The goal is to not use Django inside this directory. I'll tell why later. And another top-level directory could be infrastructure, which is basically the implementation, so Django implementation and in-memory. So we have our context, let's say admission, which is the enrollment process, formation continue, which is continuing education, and doctorate. And inside this context, we can have sub-context. So inside the admission context, we can have preparation, validation, and all the levels you need. Another example of subcontext. And here is a full example of a bounded context. So let's see what we have here. First, we have the main component of our domain, which contain models, services, and validators. Then we have use cases, which are split into read use case and write use case. Then we have the repository, and some useful classes like the builder or DTOs, which I will get back to later. And we have a test directory for unit testing. So after that, when you go into infrastructure, you keep the same structure, directory structure, but there will be implementation in them. So you can add a level for in-memory implementation, for example, and the rest is Django. Okay, so hold up. Where does Django fit in that? Well, you have two top-level directories, DDD and infrastructure, and aside from that, you can have your views, your forms, your models, obviously, and well, that's it. Let's talk about some vocabulary that I've been using for now. First term is a use case. A use case is some action that a user or an API would do. And it's split into read, which is a query, and write, which would be a command. It's called CQS, Command Query Separation. And it helps focusing on the thing that if it's a query, it should only return data and not modify it. If it's a command, it can load data and modify it. Then we have an aggregate. An aggregate is a root domain model entity. It's basically the entry point to your business to manipulate data, and it's often masking other domain entities, which are not to be used outside of the context. A repository is your way to the data, so it's basically loading and saving aggregates, or even fetching DTO. What is a DTO? A DTO is a data transfer object. It's basically a dumb class that doesn't do anything, has no business, no behaviors, and it's used to input and output data from contexts. Finally, we have a domain service that is useful when dealing with multiple or complex things like multiple aggregates or complex operations. And validator, which is used to to prevent manipulating your domain models in a wrong state. Okay. So about use cases. They're also called application services. It's basically a user story, and to determine them, you would need some process. A special technique is called event storming. So basically, you get everyone around the table. I mean everyone, developers, business, analysts, everyone, and they talk about what the application would do to highlight what are the actions and objects. And then you wrap all these things into bounded context. Then it's a good time to also establish the glossary. Then you could, after that, use event modeling, which is a technique for applying interface, a graphical interface onto what you just talked about earlier. And yeah, you kind of have your specification after that. Okay. So here is our return of experience on that, and some code. So a brief comment on Python. We recommend to use at least Python 3.7 because there are data classes, and yeah, typing is really nice too. Attitors, I don't know if it's pronounced attitors, It's is a nice library for handling attribute factories, frozen and slotted classes. And using typing makes it really easier, and you can execute MyPy on your code once you have been put typing on your classes. And as I said earlier, avoid using any of Django in DDD. Maybe you can use translations for constants, and maybe time zone, but avoid at most. Okay, so let's see an example of an aggregate. It's a root entity, so domain model, and it could be a single model in Django, but it could be multiple models, linked with one-to-one fields or foreign keys or anything like that. It has an identity, usually the primary key, which may be an UID. It has a state, which are data attributes, class attributes, and some behaviors, methods that encapsulates the business. It may contain complex data. Value objects are a kind of class that are not exposed outside of the context, but can have behaviors too. And some behavior can ensure the state is valid before modifying it, and it can be loaded through a repository. So let's see some code. So this is a épreuve confirmation, which is a confirmation exam. As we can see, there is the identity. So it's another class, which can be referenced into other classes, into your repository and so on. It is referenced into the main class as an entity ID. So we have épreuve confirmation identity. And then you have data. So I reference another domain model here. I store date and a file, a list of files. And I was talking earlier about value objects, demande prolongation, which means an extension request, is actually value objects. So here I'm highlighting a behavior, which is ask for an extension request. And it basically means, okay, create a demand prolongation object in my aggregate. Okay, so that was for the behavior. And now let's see a validator. Basically, you put some of you pass some data attributes to your validator list, and then if it validates, it's okay. You can do the next line. But if it doesn't, you raise an exception, and you catch it on the upper level in Django. Yeah, that's it. Now let's talk about a repository. A repository is based on a declared interface, hence is swappable. So you can have an in-memory version of this repository for unit tests, and even a SQL alchemy if you don't love Django anymore. So it could have 3 default methods, get, save, and delete. But it can have more, like search, get by identifier, get by some data. The repository usually return aggregates or DTOs. So this is the interface. You have the get method, the save, and the delete, the search and the delete. And as for the get, you can see that it returns an aggregate. And yeah, for the save, it just returns an identity. You will notice that it's only save, not create and update. We'll see that later. You might say that we are reinventing the wheel, but it has some advantages, namely the unit test. And let's see a Django implementation of that. So in this implementation, we are mapping the Django models that are created in our app to the aggregate and value object that we were using earlier. Get means getting and loading an object. So I'm getting an object, and then I'm instantiating the aggregate with all the data that it needs. Then for the save part. The save part is, as I said, there is no update and there is no create. It's the same thing. So we use update or create to save our aggregate, to save our model or aggregate as needed. Okay. Now a use case. Let's see the compléter épreuve confirmation promoteur command, which means, okay, I'm going to fill some data as a promoter of the examination request. We have a command. A command is basically a data class with some data. And the data is sent to a use case. With dependency injection, you have the repository that comes along. And then you load your aggregates with the repository. You start by loading things, and then you do your business, which is fill the data with it. And then you save. That's a writing use case, as simple as it is. After that, well, you have to map your use case in a message bus. So the binding is done in a big class that references all the use cases and maps the right kind of repository onto the use cases. So you usually would have a message bus for Django and a message bus for in-memory. And the in-memory message bus would be used in a unit test. Now that we have the message bus, we can use it in a view. So it may be a command view like with a generic view or form or I don't know. Here is an example of an API view. So you have the first call to the message bus that loads the last confirmation paper identity. And then there is a writing use case that completes, that fill the data that were sent by the serializers. And since you are using commands that are data classes that are easily serializable, you can use some kind of technique to convert a command to a serializer, be it an input or an output serializer. And yeah, that's it. So now the pros of using DDD after some years. Yeah, the technical complexity is concentrated in the DDD repository, which is really nice. It's just basic Python, no Django, easily testable, unit testable. And yeah, you don't repeat yourself because a use case could be reused in another view in multiple places of the graphical interface. You have business validators that can be reused between behaviors. And yeah, you optimize query in one file, the repository. And that still means that you can use model proxy and manager. So it's really focused and concentrated in one or two files. As of that, premature optimization is avoided because it's static. It's basic Python, and your code is well structured, easily readable. I would say some analysts would even be able to read it. So yeah. That is the nice thing. You are typing everything because basic Python. So yeah, easier maintenance. It has a learning curve, but it's okay. And you are basically decoupling the business from the framework. So you know, if one day you don't love Django anymore, you can switch on another framework. Now the downsides. Well, you lose the sugar of Django. You know, the rapid application developments, the auto scaffolding from forms, models. And you can still use it, but you must rework it. And some queries, especially across multiple aggregates, become really complex because if you are searching across aggregates, you would need services that are really complex to code. The ORM is a bit trickier to optimize, but yeah. And it has no support for transactions, so it could be added, but it's tricky because you're not into Django anymore, so the repository can load values and then save them, and then in another use case you have concurrency problems. So as of OSIS, most of the time the students are modifying their own data, and on the other side the manager are not modifying data every time, often. So it works for us. And it takes more time to code. So more time, more money. Okay, that's it. If you think that I was talking really bullshit, you want the exact opposite, I suggest you go to the next conference after lunch by Adam Johnson, which will be data-oriented Django. Thank you.